Welcome, Elaheh Momeni, CTO and partner at eMentalist.ai. She'll share with us how to think in graphs, the cognitive foundations of Agentic AI. Elaheh, the stage is yours.
Thank you very much. Hello, good afternoon. I'm very happy to have this tutorial session with you today. In this 1.5 hour session, I would like to give you a short introduction how by using the graphs we can build the better explainable and powerful agentic system. So shortly about me, what is my background? I have an academic background in computer science with a specific focus on the artificial intelligence and data analytics. I work as a lecturer and researcher at the different universities, the University of Vienna, University of South California, University of Michigan. I published many different research papers and at the moment also at the University of Applied Science Technicum in Vienna. And about 10 years ago, I founded the eMentalist, where it's a AI solution provider company where I'm responsible for technical development of the company. So basically, shortly also about what we do, what the company is dealing with. We are, as I said, it's already 10 years. We are in the market. We were lucky to work with the amazing clients. We have already launched and done a successful project. And also we develop a solution for the real estate sector about the data quality management, which is already launched for 24 countries, and it's used by many users. So about our content, about this tutorial, what we want to do, I would like to start with the short introduction, a background. So just starting to do some warm-up, let's say, and then I will go through the what is the graph rack and what is the knowledge graph for the ones who are not familiar with the knowledge graph. Then we move to the agentic AI, to the MCP, and I will show you 3 different use cases. I discussed with 2 different use cases showcase. So first use case, I will show you that an ESG agent, environmental social governance reporting agent, using the RAG and knowledge graph, and also showing the synergy between these 2. And then I will show you about the facility management, a system tool that we are currently working with. We have lots of new customers, clients in this direction. So I would like to share some of the technology we are developing there and what we're doing there. So basically what I understand, these sessions will be not for the advanced, not for the basic. So I just try to build it up in a form that will be for the medium, the one who has basic understanding about the RAG and about the large language model. But of course, I'm not going to the advanced level, and it's not also so basic. I'm just expecting that the audience have some participants have some basic understanding about this concept. Very good. Maybe if we can do it, I already arranged that. If we can, for me to get better idea, how should I focus? Where should I focus my morning? Could we do shortly? Who is familiar with basically knowledge graph? You can just raise your hand and just let me know how many of you already are familiar with knowledge graph. That if I can see. Okay, so I see there are some 4, 5, 6, so around 5 persons. And so who was working with already familiar with the concept of the MCP, building some agents? Okay, already 2. Okay, nice. Okay, so that's good. Thank you for giving me idea. Let's start with, yeah, as I said, about background. As we know, large language models are integrated in our everyday life activities. I guess you, like me, have always a tab open and you have your large language models somewhere beside you, and you're using it for all activities you are doing. So why it's like this? Because it's understanding a natural language, it's generating, it has lots of know-how and knowledge, which for the person, each person maybe cannot have all this expertise. It can do different tasks like summarization, question answering, content generation. It has a multitasking somehow, and it has some kind of human-like interaction, engaging in conversation, and it's helping us to communicate in a way that we as a human communicating. That make it very attractive. So where we want to go, we have started from, as we know, we have started from very earliest systems, like when we're talking about intelligence system, we are starting with early system like a logic-based system, which was very limited. It was based like symbolic AI, very limited in the development. Then we move to the area that we have some kind of machine learning models, and we have a possibility to train. We use the algorithms to train the new models. And then we move to the area that we develop generative AI generative model, which are the model can generate, is not only learning the patterns, also they can generate the content. And basically in this area, we know that one of the biggest milestone we had, it was when we had ChatGPT, OpenAI was opening the ChatGPT in the public. So it was really a milestone for everybody in AI community, that everybody is starting to use the AI. It was not just hearing about AI, people are starting to using it. So it was really a milestone. And then we have that. Now we are coming to the age of we are developing the AI agent. I will going to discuss a little bit more detail what about this AI agent and what is the difference between LLM and AI agent. And then we are moving to the area that we want to build up the artificial general intelligence AGI, which is we want to ask everything and ask just from AI. So, but very well, that's a very nice journey. We are all in it. But what about the corporation? How the companies can deal, and what the companies can do with this technology, and where they are standing. We know that the companies, corporation, they have large amount of internal knowledge and data. So this is they have, we can say, from all the value chain of the companies, from the CRM up to marketing, up to financial, up to whatever that to sale. Everything is at the moment we have lots of digital tools that is we are enable us to collect lots of data, and we know that this is enormous potential in using LLM. But other hand side, the actual LLM are basically only able to answer us in a very general form. So when they don't have any idea about our internal data, because internal data basically are sensitive data, which is closed, and we don't have it publicly on the web or under any kind of open repository. So these LLMs are not, they don't have access to this data. So basically, when we're asking them the question, what could happen, they can hallucinate, they can have this lack of grounding, they don't have about our data. This is they train based on the data that it was available to them, but they don't know about our contracts, about the protocol, about our databases. And other problem is that they have also whatever their answer to us, it's like a black box. Although that we have this kind of deep search and deep stuff already, which is giving us a little bit more background about references, but still they are we cannot understand, and we cannot ground it where this answer coming from, and we don't have any reference to the answer. We cannot understand how the answer is generated. So what is the solution? Solution is that many people are starting to develop or to combine retrieval model with the generation model. So this combination means that we using the whatever data we have in our companies, we indexing them, we build the embedding model, we embed them, we are building some kind of index, vectorizing this data, and we give this data, this vectorized data to our LLM as a context. So this LLM then can use this knowledge to generate the content. So we are a step better now. We can generate the content based on what we already provide to the LLM. So the context here is very clear. So it's enabling us to reduce the hallucination, is enabling us to give the access to the internal, also external data. We just say, okay, I just want explicitly my LLM answer the question from this external data source about some statistic about population or whatever, about the weather, or we just can decide what we want based on what the LLM want to answer the response or to respond to our questions. So basically, very good. This is a very good step. It's some kind of, we are getting to the one step further, but one of the problem is this RAG system basically have some limitation, because they are also, we are vectorizing, but they are still have some limitation. And this is exactly where we are coming now today. We want to discuss, and this is the scope of our today workshop or tutorial together, that we want to discuss about further possibility, like including graph, including and also connection to them. Okay, maybe I just missed this part. I should also add this, that basically what the corporation also they have the company, there are also lots of connection to the other internal, external sources. There are connection to the data sources, data ROMs, data banks, any kind of ticketing system, any kind of planner. So we need also this connection to get our data. So here we now coming to this, we want to show some application, some kind of building up solution that combining this graph RAG concept with this MCP concept that I will discuss it in the later, what is in detail, basis for enable us to build up the powerful and explainable agents. So first part, we are going to discuss how we can leverage the graph-based technology, basically knowledge graph. I will give you also short intro about the knowledge graph for better, richer, and building up richer semantic and knowledge. And also with combining the graph RAG with the MCP, we are enabling our LLM and enabling our system to seamlessly interact and communicate with the other system and get the data to our system. So I just build up some kind of like a puzzle, and I want to go through the different part of this puzzle together in this next hours. That we see how this puzzle is, each of these component completing that we build up at the end a good solution. So let's start with the first part. What is the graph basically mean, and what we mean all the time with this graph and knowledge graph? So as I said, traditional RAG system have some limitations. So it's heavily dependent on the quality of indexing. So it's a very engineering task. So we should build up lots of experiment and we experimenting a lot. Which kind of indexing, which kind of embedding model, how we can define our similarity, all this kind of stuff have an effect that how our RAG system works well. And still, as maybe some of you are familiar with, if we want to have a high performance and to make the RAG system works, we need to do some chunking technology. Chunk mean that we take our content, we separate it into the smaller part to give it to the system, because we give in whole the content, maybe it's too much, and it's most of the LLM cannot deal with that. So it's very, when we're doing this kind of chunking, maybe we lose some of the part of the semantic and connection among the data. And also limited reasoning and the relationship, because it's like an index are well, so it's given some based on the embedding models, and this it's nice, it's good, giving us some basis of the understanding of data, but it still is not giving us the complex inferencing. And also not enabling us to do the multiple interconnected data points and understanding this interconnected data points. So it's not possible to do inference in a complex query, basically. So what we do, we add in the acknowledge graph, so interconnected the structure of the data to our rack system. I will describe it in more detail later in the latest slide. But basically, we build in some kind of retriever interconnected class. So it's not only an index or vectorized data. We also giving this rack or giving this graph, an old knowledge graph, as a basis to our rack system. So what is the knowledge graph? We talk lots we many times we mentioned this term, but what is the knowledge graph? Basically, a knowledge graph is a network of all real world entities, like person, companies, location, and also relationship among these entities. Like here in this example, Tower is a place. We see that there is a place is a node, and the is a relationship. And we can say also Tower is located in Paris. Paris is another entity. A city, Paris is a city, Alice is a visited Eiffel Tower. So we build all the things, all what's happening, all the events, all the relationship among these entities as a graph. So the graph means we have nodes and we have relationship between these nodes, or among these nodes. So it's like some kind of, it has some analogy with our brain memories. We have also in our brains having some kind of interconnected, from the entities. And here exactly we do same. We build up this network. And as we want, we just a little bit more detail about what is this graph and what are the components of this graph. Let's look at this simple two nodes, Dan and Anne. We have two nodes here, and the relationship is love between them. So basically we have nodes. This is that most important component of the knowledge graph, which is defining, representing object, concept, and any entities. And then we have then we have the relationship among them. So this relationship basically are edges between these two entities, or among all the entities. And here we see that loves is, for example, the one of the relationship. I will show you an example about this environmental social governance. For example, we want to understand which social governance ESG factor has a connection to the specific company. So this is one relationship, basically. And also, furthermore, we have some properties. We have properties for the nodes. We have also properties for the relationship. For example, in this case, for the node, we have a person, and person has a name, family name, address, email address. So these are the properties we give into our nodes, and this enabling us to associate more content and more context to the nodes. Basically, it's like a metadata we give into the nodes. So in any time anybody has a question, can please raise the hand, and I will be happy to get the question in the middle. Yeah, this means that what we have, when we have this knowledge graph, what is given to us? What is the power of knowledge graph? Basically, this is deep semantic understanding, capturing meaning, type, the direction of the relation, all these things giving us some kind of very ground basis and very detailed understanding about the context we want to work with. Like also it's giving us the possibility to do some complex reasoning and inferencing. So this means we enable us to sophisticated queries and multi-hop reasoning across indirect links. For example, which other company were affected by similar climate issues as company A? So it's like when we have connection between two companies and we know what was the effect of one company of the other one, and we know the third company is in relationship with one of this company, we can do this kind of multi-hop reasoning and questioning. And also it's giving us the clear visual representation. The connected structure make complex information intuitive to understand, debug, and audit. So because we have very clear understanding how we build up this knowledge. I like this image from the paper from Encyclopedia, that it's also what is the maybe some of you saying, okay, LLM also basically is able, but in reality there is a difference between knowledge graph and LLM, because each of them has a advantage and disadvantage. The basically a disadvantage of the LLM is they have implicit knowledge. There is hallucination, which we talk about. It's that black box. They have a lacking of the domain and a specific knowledge. So it's everything is very generalized there. On the hand side, the knowledge graph, it's a very structured knowledge. We have understanding about all this connection. It's very we can very well explain it, and we can evolve this knowledge. The other hand side, the positive side of the LLM is this language processing that it can generalize. It can generate the answer response in the very natural language. And also but the disadvantage of the LLM knowledge graph is that incompleteness. Sometimes building the knowledge graph, it's an unseen fact that maybe we are not able to pack and model everything, because it's some kind of has it's whatever we decide to put it into the knowledge graph is included, and it's some kind of somehow it's on our control, because knowledge large language model is based on the training data, but knowledge graph is some kind of, we can include part of the fact or not, but basically there is some trend that the knowledge graph building itself and in some kind of unsupervised format, the knowledge graph developer. But anyway, what we want to achieve, we want to get the positive part of the both. We want to get some kind of building some synergy between LLM and knowledge graph. So we want to use this knowledge graph enhance LLMs. So this means that we use the knowledge graph as a context for the large language model. So it's giving us a structure of fact. It's giving us domain-specific knowledge. It's giving us symbolic reasoning. And also, on the other hand side, we want to use the LLM to enhance the knowledge graph. So this means that we want to LLM augmented knowledge graph. So this means that we use the LLM to extract the knowledge from the documents, from or data, and we put it into the knowledge graph. So we want to build up some kind of synergy that knowledge graph give the factual knowledge to the large LLM, and LLM do the knowledge representation for the knowledge graph. So if we have this kind of synergy combination between these two, we could have positive, very powerful effect of both. So one of the technology, I just want to check if there is any question. Okay, no question. So what are the technology we are basically doing to do this kind of knowledge graph? One of the at the moment state of art is, for example, libraries or technology framework is the Neo4j, the graph database, which enable building up this kind of knowledge graph. So it's basically it's also enabling some kind of query language, like that we have data bank, so like a SQL data bank, and we have a SQL query. Here we have a Cypher query. We build up this knowledge and we can query out this knowledge. So let's here show what is here saying. So for example, an agent asking the LLM a question. The question will come to our vectorized index, basically, let's say, our classic RAG, and then the classic RAG has in the context has also this in background has this knowledge graph, which is deployed on the Neo4j. And this enable us to have a better context, better explainability about the answer, and it's giving to the LLM the answer back, and LLM generating based on what the knowledge graph generating. I will show you as example how this working. An example of the notebook. Good. Where we are now? We talk about we have large language model, which enable us lots of possibilities, so like generating content, communicating in natural language, and we have a RAG which enable us to make our internal data or any data, external data, as a context, using it as a context for our large language model. That large language model not generating only the general, not producing or generating general answer response, but although it's generating based on the RAG, based on this content that we give it as a RAG. So RAG is basically doing vectorize, is indexing our content, and we said by connecting and putting the knowledge graph in so this means the large language model using the graph RAG, the RAG system, which is augmented by the knowledge graph, we already also giving the whole system more power, because then we have a system which is very powerful for inferencing. It's very explainable. We exactly know how the large language model inferencing is not just a black box. We can in very detailed understanding where is the answer coming from. So before we go to the next step to understand where is this missing part of the puzzle, I just wanted to see if anybody have any question, any idea until now, anything that is not clear. Just if you have question, raise your hand. I can see, but it looks like there is no question. Okay. Okay, so if there is no question, I will continue about this part, what is missing already, about what we talked about until now. We said, okay, there is one. Let me see. Okay, nice. Okay, so let's say what we have until now. We said let's say we have the best system that already have the knowledge graph back of it. We have all the context. Our LLM is very clear, can answer the questions, and it's very explainable. It can infer. But okay, what's the next? How we can get the data, how we can do the actions, how we can get to the level that we say it's an agent. Because at the moment, only what we have is only a system can answer some question. We write the prompt and system can answer the question. So we are coming to this part that basically what we are understanding from LLM is totally different from what we are understanding from agentic AI, or what is the agent is. LLM basically is reactive. It's a typical that responding to what we're asking is the stateless. Primarily, we know that we have multimodal. It's also video, audio, and all of stuff. But primarily, it's generating text. Is very based on the text base. It's limited to the external interaction, so rely on the internal data. But other hand side, we want something that do some action in our system, that is not only just generating answers, so also do some stuff in our answer. Furthermore, send an email, pick up the data from a data set. I don't know, just querying, build up their own query. So we want to have more actions. We don't want just reactive. We want proactive. So that's the place that the agents come in the play. So they are initializing actions to achieve defined objective. It's also capable of interacting with the external system, like APIs, like database, whatever web search, and they can have a memory on long-term state, so they can keep the history, enabling learning and adaptation. They are able to plan and reason, break down complex task into plan execution step, and reason about the outcome. and also can do decision making. If that, they can do that. So there is some kind of some kind of they do some process and flow about the stuff. And how we can do this, how we can connect the stuff, how we can get all this data from other places, communicate to the other system to do this stuff for us. That's where the term MCP will come into the play, which is you see that I put the last part of this part of this puzzle. Basically, the puzzle can have more components, but I just, based on this tutorial, I mean, that is a part. So MCP basically, it's our model context protocol is an open standard developed by OpenAI to make the AI agent more powerful and interpretable. Basically, we can say it allows models to securely connect to the external tools, data source, and API through consistent some kind of interfaces. They are enable us to build up some agent, a bit of agent, and they are providing the modular and some kind of like a plug and play architecture. So instead of hard coding integration, you can connect your model to various systems like databases, email, also in API, and it's make it everything much easy. So maybe some of you saying, okay, so we had API many years. We worked with the API. What is the difference? API also were here, and they're working well. Yes, of course. But what was the problem and limitation of the API? They were, as we know, we have extensive documentation to work with the API. If we wanted to connect to each of this kind of platform that we added, that is shown in this image, to the email, to the Slack, to the database, to the drive, you should have understanding different documentation, different protocol, different authentication, and all this make it very hard to work with the API, because each time for building such a system, you need to understand and have a persons who program all of these things. But with the MCP, we have this standard, which is we can think about is like a USB. So everywhere is working, everywhere is same, everywhere has the same on some kind of protocol level authentication. It has a abstract network consistency, so it's giving us lots of power, which is not anymore. We are dependent on the one documentation. It's some kind of it's a base standard which enabling you to build up some kind of connection and communication to any other system, or also inside your own company, building up that connection to the different system. You have an AI, central AI, you want to pick up the data from one data set and then sending the email to the other. So you can build up based on MCP without having different APIs and different codes and whatever. So this is giving us a lot of power in that case. So basically, if we summarize it in that slide, so it's a data source connecting to the data sources like local file databases. It can connect to the search engine, calculator, enterprise actions like Jira, Git, Slack, and is also enabling us to do them, as I said, the flow workflow. It's also building up the process, execute a specialized prompt and operation. It can decide what can we do after one other step is done. So it's a key benefit of that using the MCP is for the developer, reducing the development time and focusing on the AI logic instead of building some leading documentation and staying at the software engineering level. How should I understand which API, which kind of response? All this stuff to understand is a very standard, giving lots of power to the developer. It's for the AI application and agent. It's like ecosystem access, enhancing the capability of that whole the system that seamlessly connect to any other platform. And it's for the end user, it's giving the more capable seamless automation. So very easily they can or connect to the system, and they don't have a problem to build up different APIs and different connection and documentation. How that's work? What is the MCP architecture basically working? we can say that MCP act as a bridge between AI model and external system. It defines a standard communication layer where the AI model run as a client and external tool or data sources run as a MCP server. They exchange structured messages over a secure, some kind of JSON-based protocol. So it's make it everything very standard and easy to work with. When the model needs information or an action, it sends a request to the MCP server, like fetch user data or run a SQL query. The MCP server executes that action through its own backend or API. It returns the response to the in a standardized format to the model, and which can be interpreted by the model. So this architecture can dynamically discover, call, or reason over the external data and external sources. And yeah, and it's very modular, portable, and scalable basically, because there is no specific protocol or specific. It's very everything based on this standard. Well, I discussed about this client server part, but what are the technology at the moment? It's giving you fast development. You can use like some kind of, like for the client part, you can use the fast MCP. Fast MCP is very lightweight developer framework. For quickly building and running the MCP server, it's designed for speed and simplicity basically, and it's some kind of build up in the Python and Java. It's giving you some way of quick start toolkit, so you can easily build up this client. And then you have the server part, which is basically MCP server lets you connect to the MCP running MCP server connecting to the remotely, like in cloud or another machine. It and it handle secure communication, authentication, and message routing between AI model and those external MCP server, let's say. This basically allows our agent to access enterprise or cloud-based data safely and without having to run everything locally. So it's we can connect to the any kind of server services outside of our also ecosystem. Good. When we now come in, as I said, now we have all these four parts ready. This means we have already our knowledge or data. We give them our knowledge, we build it up in a knowledge graph. So it's some kind of, we build up this graph, we use it in our backend, we empower our rack system with this knowledge graph, with this rack system, with this graph system, interconnected data. And then we give this to our LLM as a context. So LLM has a lot of power now. It cannot just generalize producing the answer from anywhere, just a general answer. So it's answering the question based on the knowledge and the information and the content we provided as a context. And also with the MCP and all this, we can do seamlessly interconnection. So it's now we have some kind of this knowledge graph provide some kind of provide the reasoning also. So we can give the reasoning possibility to our hold the system, and with the MCP we can connect to that, we bring the data with, and we do lots of inferencing, and we can have a better power than only having the index-based rack system, which is only based on the index and only based on the vectorized data. So it's giving the trustworthy to all the decisions. We know that where is the data coming. We know how the system inference, because we can see interconnection between the nodes and our relationship. All the things is clear now. Everything is more explainable and trustworthy. Good. Now I just want to move to show you these showcases, to show you how in reality, what kind of application we build up based on this technology. Before, I would like to check if there is any question. I see there is. I thought there is any undeciding what to do when comes from the LLM model. In general, the way. I thought the reasoning and deciding were the Oh no, that basically what I mean, the reasoning and deciding exactly. No, the deciding and reasoning is basically done by the RAG and or RAG graph RAG system. MCP is mainly doing do the connection and basically bringing us that what we need to bring it to the action. Is communication, all the communication, all the connectivity is doing by the MCP. But basically, the main reasoning part, inferencing part, is going to be done by the graph RAG and LLM part. I hope this is the answer to your question. I hope I understand it correct. Any other question? So no. Okay. So let's show you as I turned two example of about two showcases. One of them which I prepare. So let's give you a short introduction. What is about? I many times discuss about ESG, environmental social governance. Basically, environmental social governance, if it's not familiar, you are not familiar with it, it's a framework used by the investor, regulatory, public to evaluate to what extent a corporation or a company works and how what these are some factors, like factors related to environmental, how the company dealing with the environmental factor, about the energy saving, energy consumption, CO2 emissions, and also about social concept, how a company caring about the social factors, diversity, whatever we put it at a different factor we can define, and also governance, how what the board diversity, about the security, all the governance thema. So each of these category has a sub factors. So there are different factors defined by different frameworks. And exactly this bring the complexity of this kind of providing ESG reporting for the companies. If the investor or a bank or another company want to work with this company and to want to understand how is the ESG image, how the company works well with regarding the environmental social governance. Normally, there is no standard framework that is saying to me, okay, this company caring about this environmental factor, this social, there is no common standard factors. Each framework has its own factors and own criteria. So it's very hard to compare and has some kind of standard. Yeah, it's give us the possibility to compare the company. Maybe one framework giving so much focus on the environmental, but no focus on the social and governance. And also data qualities. Many times the reports are provided are not missing the lots of data availability because companies, until that they collect this data, it's very hard to collect this data. And to build up the KPI, what is the correct KPI to build up for the diversity as a social factor? How you can define it in a right way. So anyway, that's showing that there is lots of challenge. But what we wanted to build up, we wanted to see if we can use alternative data that collect the real-time alternative data from the third-party data. So like whatever is written in the web about the company. If we can build up the image about the ESG, let's say ESG image of the companies. So what we did, we tracked the daily evaluation of the volume of the discussion, and also we want to understand if for the specific time we can say from second quarter of the 2024, what is the ESG image of the company X? So we wanted to get idea about this. So what we did here, we use knowledge graph. So we built up all the factors which we find it in the different standard. I will show you in the code what are these factors we use. And we build up the knowledge graph, and whenever we find a new information on the web about the company, we add it to the knowledge graph. So knowledge graph is somehow giving us the very interesting basis and knowledge about the companies and relationship to the basically to the ESG factor. So here is that one screenshot of the Neo4j. For the other example, I will also show you the live the Neo4j. But this is, as you can see here, this is the knowledge graph we build up. So this orange nodes basically are company, and these green nodes are. When I'm moving to the next slide. Okay. Okay, so you can see these are the ESG factor. For example, it's saying the ESG factor are the green nodes, environmental, and it's about plastic reduction. So we added different ESG factors to the environmental, social, and governance. So this is that, so orange one, yellow one, it's a company node. The one green one is the ESG factor, and what is the red one? Basically, red one is the source of the information we found in the internet. So let's say if it's and we have a URL of the of the source, and we also, to have it more, give it more power to the whole system, we embedded whole the text of the article or whatever we find. As a embedded vectors, we added to the knowledge graph. So it's, you see here, it's an embedded vector of the whole the text of the knowledge or of the source of this article or social media post. And what is here, we have another component which I told you about. It's a relationship among the company, and we have these lines and edges, which is the relationship between company and factors, company and sources, and which sources is related to the which company and to the which factors. So we build up some kind of all this detail, and we have also added time when this relationship is valid, from until when to when is valid this relationship, because maybe a company did something for a specific factor for the specific period, and then at the other period is not anymore the focus of the company. So we added all this detail as a properties. And also, what else we added as a property? If it's sentiment, we added sentiment. If it's a positive or negative or neutral. So it's basically positive, negative was most important. We wanted to understand if the company, regarding to this specific factors, doing positive or doing the negative. I hope the case is clear. I just look again if there is any question before I show you the code. Okay, there is no question. Good. So what basically here I want to show you at the in a notebook, a Jupyter notebook, how we develop this is. Oh no, first it's interesting to show you how this system basically works. Here we have some front end. Let's say I will ask a question. Here we have we can just randomly select one question. How is the ESG performance for Sony and Nintendo in March 2025? Maybe asking, so you're saying, okay, so this basically also will done by the GPT. GPT can also do, or any other language model, large language model can also do this. Basically, yes, but what is here different? We wanted to have for a specific time frame the answer. So it is very, for us was important that not all the general answer, because if you are answering same question, it's giving you very general answer. So what was the goal here? To extract exactly the articles or the content which was exactly for this time period and about these two companies, and giving us some result. So now basically it's live, it's analyzing the old data. basically searching in the web, it's being in all the related articles related to these two companies, and then it's generating. Let's go to the level until the answer is generating. It's taking a little bit time, not too long. It's some minutes because it should collect the data, it should build up the knowledge graph, and based on the knowledge graph, it's generating the result. But let me show you some high-level information about how this we build up. I will not go into detail of the whole this notebook because it's lots of detail, but I will to show you how we build up the cipher query, how we build, what are the prompts we wrote to enable this. First of all, we build up our Neo4j client. So you see that here we build up our Neo4j. We also use the EXA API. EXA is that actually a tools that enable you to crawl the data based on the search query. So we use that because it's also giving us the time frame, enable us to give a time frame, which time frame we want. And this is the Neo4j platform. So you see that these are the graph. It's integrated to this for this platform. This is just a sample node. But yeah, that was the first setup. That now we want to start integrating our knowledge this is just starting having some basic knowledge into to our graph to build up some first setup of the Neo4j. But let me give you in more relevant stuff, because as I said, the notebook is too long, and I just wanted to show you part of it, which is more interesting, not about the program in all the detail. For example, if we wanted, with the EXA, we are searching. We are searching for these two different companies. We are giving you. We also saying you are an AI assistant that creates kind of search queries. It's also based on the. It's like an agentic format, so it's bringing us the data. Now we are going to that. It's running executing that query. But what is that interesting part is it's also we did lots of parallelization. If you see that here we have execute parallel document loading, because it's bringing all documents. We need to parallelize this process, otherwise it will be too long. And now we want to have, let's say all the documents are collected, all the information are coming. So here is also, you see that the answer that we were asking. So it's showing us, okay, saying doing some analysis for the March, because we just only give 1 month, so data is not too many data. It's analyzing and saying, so there was no activity, for example, about environmental social was fine, but there was activities about governance about these two companies, and it's comparing and also giving the explanation about the result. So what exactly here we want to do, you saw that it was a start fetching crawling the data, finding the articles related to the ESG, related to these two companies that as we give Sony and Nintendo. So it's calling, when it's bringing the data, now exactly as I show you in the slide, it's a first part. We want to use the LLM to extract the knowledge extract the knowledge and build the knowledge graph. So first step, we do this, we say analyzing the following article, whatever the article is from, and extract these ESG factors. And you see that we define some ESG factors. We're saying for the environmental, climate change, carbon emissions, water usage, waste management, biodiversity. For social, so we give in our prompt to the LLM prompt the complete instruction that what we want to get from these documents that is crawled from the internet. And that when we have this, we build up some JSON. You see that it's as output, we're saying, okay, now create our relationship. So it's some kind of, it's saying impact ESG is relationship between company and ESG topic, and is also giving the sentiment. So build up all these things, as when you find the ESG factor, when you find the company in the text, just build up this kind of relationship. We're expecting that our LLM using this prompt and using this instruction and extracting the knowledge from our documents, which is crawled by the XAI. And then after that, we have already extracted. You see that we all the time having the parallelization to extract, embedding, because all these things taking longer. If you want to get in the less than some minutes answer, we need to do parallelization. So I will pass this part. And then now we're coming to the part that we want to populate the graph into the Neo4j. It's a next part that we want. We already have our graph, but now it's we want to populate it into the Neo4j. So as you see, we have already here some cipher query. We're saying, for example, if the person is already in our graph, or there is a company, that just merge it. If there is not, build up the new entity in our graph. So if there is a Sony already in our graph, there is no new, we will not build up the Sony as a new company. There is already, will merge this information to the graph. So this is enable us to not build in a duplicate, and also reducing ambiguity, because sometimes the name of the companies, for example, think about Fachhochschule Technikum Wien, or there is somebody saying FA Technikum. So it's both of them is the same name, but if it's you are not combining, not doing this kind of merging, basically you are not you will have a very ambiguity in your graph. So with this match and merge, you are populating your graph basically, and then you execute population. But then I want to go to the last part, which now we have our graph. The graph is ready. It's in a populated new information. Now we want to have generating the result, which you were seeing here. All these results we want to generate. Now what we do the other way around. Now we use the graph rack that we have already built up, and now we want to use this graph rack and LLM using this to generate the answer. So basically the answer was generated. Now this is the instruction: compare this company on ESG factor, mention this and that. So it's now we are giving the context how to generate such a result, and giving us this interpretation about this query using only the graph information. Now what is the positive about it? That we completely limited to the information we give it to the graph, and we know that the information where is coming from, because we already know where is the sources, what is the information it's on the graph, and all the result is generating here basically. It's very explainable. We have idea where is that. It's not just somehow we don't know if it's a system doing hallucination about Sony or Nintendo answer what is given to us. We know where is the data is based on. Yeah, that's basically as I told you that it has a lot of detail to run it, but I just wanted to give you idea how this synergy between LLM and knowledge graph. First, what we did, we used the large language model to extract the information, to add it to populate the graph, and extract the information in detail, entity, relationship, properties, to add it to the graph. And then we use the graph as a basis for the knowledge graph, for the large language model, and we generate the result based on that graph data. So this is synergy that I was showing you also in one of my slide, basically this slide, which we were talking about. We use the knowledge graph, and we use the graph then for the LLM, and the LLM then for the knowledge graph. So it's some kind of this synergy basically enable us to build up this application. Good. Any question about this showcase? Anything unclear? How does it work? Thank you. Very good that you like it. Yes, that's Basically, as I'm saying, the main advantage is that you really enabling explainability and you give that more inferencing into your system. Is enabling you to do more complex inference. So now I have 30 minutes. I would like to show you the next two showcase. Basically, is in one. I will show you two parts, but first I need to give you more context what is about this application or what we are building or working on it. Basically, this application, which is currently we are working with, it's about completely different direction. So building management, so building maintenance management. We know that facility management is a very some kind of risky job. So this is that I see that my slide is in German, but okay, why is German? Okay, but that doesn't matter. I will just tell you that the facility manager basically, as we know, it's they should do that maintenance calendar based. But what is happening most of the time, that sometimes the people are missing that when they pass there's some kind of maintenance should be done in the building, and we as a persons who are living in these buildings, we expecting everything is okay. The asset manager also expecting that the facility management doing their job correctly, but in reality most of the time many things are missing, and small missing things can meaning that a lot big risk for the whole the building and the people who are living in the building. So what we build up, actually, as it is written in German, I'm sorry, I don't know why it's mixed up this slide, but basically what we build up or we building, we building some kind of KI assistant for this facility management. So this means we are not building completely facility management tools, but we are doing some kind of assistant for the asset manager to have a better control of the facility management job. So this means this tool enable the asset manager to see if there is anything missing by the maintenance protocol, if any deadline is passed, is any agent if any kind of things is missing. And if that means everything is completely agentic base is built up, so there is no need of human interaction in the whole system. So what this means, the system get all this protocol that, as you see here, this protocol are also in different format, is handwritten up to table based up to checklist. So it's a different type of the protocol, but we get this protocol or MCP connecting to the data source and data RAM or data bank of the customer, can collect this data and understand, extract the information. And we then understand what is the missing, what are the whole the damages, or what are the whole the things that in the building should be repaired. It will make a list. If there is already registered these things in any planner or ticketing system, it's all fine. But if it's something missing, is adding the new agent is activating based on using the MCP. I will show you this MCP part, and build up the ticket in the system. And then it's based on that, the person will get a notification, a right person will get a notification that something is missing in our deadline is passed, and nobody did the maintenance in the building. So basically everything hopefully will be always good after that. So let me show you a video that I have about front end, because also we enable the user to have this front end. I know this front end is German based, but this was on purpose I used, but the slide was not on purpose, but the German part here is on purpose. I wanted to show you that how good it works with the different languages. It's not only we can parse and understand the whole protocol in English, also in the other languages very well working. But let's say this front end showing that, okay, the protocol is coming, the protocol will be added to the system, or as I said, MCP protocol, based on the MCP, you can get from the data RAM SharePoint, data RAM box, whatever you have it. It's picking up this protocol, and then protocol will be analyzed. As you see, the system is analyzing, it's saying, okay, the protocol when updated, then the front end is also updating, the status of the object is updating. And if it's finding the new 5 problem in this building, which is already not registered in the beforehand. So it's this 5 problem find. So it's sending the new agent is activating, is sending an email to the right persons, and you see that the right person get informed, responsible person, and furthermore, also it's creating the Jira ticket in the ticketing system. Now all the 5 problem is registered in the system, and we have already a very good overview of the problems. And we have also, of course, we have chatbot that you can talk and ask about anything about this protocol. So just give you idea how this system works. But what is the power of all the things in backend of the system is not understanding the protocol and these things is basically we have the knowledge graph back of it, which is enable us to model all the standard norms, everything which is about legal stuff. So when we have existing facility, and it's already added to our knowledge graph, and then we have new legal stuff coming, new document coming, new contract coming. Now we know that, for example, for a specific elevator, instead of 2 times per year, we should do it 3 times per year. So it's also important that to have update, maybe the facility manager missing that update about the legal or norm. So what we do, we are matching this, we are adding to the knowledge graph based on the norms we are fetching from the MCP, connecting to the different norm system, to the different standard system, collecting these things, and we're updating that for this specific facility like elevator, you need to do 3 times instead of 2 times from the year to 2026, for example. And this knowledge graph is basically our power of the system, because it's like a main brain of the system, can understand and can update itself very well. And this is able to do with MCP and connectivity to the other system to bring the data to the updating our knowledge graph as a basis. So this knowledge graph basically understanding a lot from the real estate sector, from the facility management sector, from the all the norm and the process in this area. So that's basically a use case. I will show you a Neo4j this knowledge graph that you get the idea, but let's go check. Is there a question? No question. In the Neo4j we have also a sample, because the data is for the customer. I just prepare for this tutorial a sample of this graph. As you see here, this is a sample. Like if I'm zooming in, all this there is a task, or there is to-dos for a specific facility. This is shown by this green nodes. As you can see, these are the tasks. It's written here, maintenance task, that maybe we find it in the new norm, in the standard, or in the new list of the contract. So we add in this, like this Luftungs, everything about air condition. And so this is that the facility have a specific technical task about airs. I don't know exactly how exact translation in English, but it's a facility about air, and then this is showing all the facility related to all these purple nodes, basically all the facilities that should have same task or should be done same stuff, so same to-dos should be done. And also in more detail, as I told you this before, we have added all detail of how many times should be done one task for the specific facility, and is it for a specific region, maybe it's a different, maybe it's the same elevator, but maybe in the specific region the rules is different from the other region. So maybe it's 1 time is not enough for a specific region, should be 2 times. And this is all integrated in this embedding and all this stuff that we have in our graph. So if I'm to the detail, you will see these are basically all our detail of the all different detail of the component of these facilities and what to do is, and all this detail of that you can see all the relationship that has task and all properties under it. So this enables the system, as I told you, this is not our original knowledge graph, because our original knowledge graph is also lots of information about the customer, but it's just somehow giving you idea how this knowledge graph in the background working. And this enabled the system to have better context for that, for the generating that, understanding the protocol, and also on sending the right emails or creating the right ticket into the system in the right time. If there is no question, or is there any question? I will check once again. Okay. I will show you another another notebook, just to give you idea how this MCP and this fast MCP and how this working. Because in this example, as you saw in the video, I show you that when there was a problem found out in the protocol, it was sending the right email to the right person, and then it's creating also the Jira tickets. So that place you are seeing that it's creating automatically a Jira ticket, and also in the email is also added of the Jira and second. So you can check these problems. It's already an email sent, but it's also you can see the Jira and who is doing this. And basically it's a MCP agent. We have an agent background to using the MCP and doing this kind of task in the background. So I will show you basically a notebook just to give you idea about the flow of this kind of things. I will definitely, as I told you, all the detail is not necessary for this tutorial. It's just about you get the flow, how this kind of MCP protocol working. Basically, first step, what we did here in this notebook, as you can see, we set up our connection. We have connection to MongoDB because all our problem, all the issues we find also are added to the MongoDB because we are still trying to understand what are the best way. Is it just adding the problem into the MongoDB, or shall we also add to the knowledge graph? To be honest, we are still experimenting with all this detail. But to first step, we did it. We add them onto the MongoDB, these issues. So we are also connecting all the issues to the MongoDB. We have the connection to the Jira. We have a connection to the OpenAI because we're using the OpenAI models in this case. And the Asia-based models, as you know, it's a very sensitive to use the OpenAI itself for some of the companies. So it's necessary we set up the dedicated instance for them. And as you see here that we do here the first we do the MCP configuration. If there is a fastest MCP configured already, we have it. Otherwise, we should configure that we're saying we want to have the Atlassian, because Jira is part of the Atlassian ecosystem. So we do that this MCP remote, and because Atlassian providing this MCP is very standard from the Atlassian, give us the possibility to use that MCP. And we initialize all the clients. Here you can see all the clients for the Asia, for the fast MCP, all the things with initialize. And also we instantiate. I will just skip it. Here we first step, what we do, we query or MongoDB to extract all the issues we find, what are their issues, and to whom it should send that, what is the status, what are the description. After that, we do the authentication to the Atlassian, so we do the MCP of the Atlassian for the Jira connection. We do the connection to the Atlassian. You see here that this authentication, and if there is an error, we do that error handling if there is no failing that authentication. After that, after we have this, we already checking also if there is a client, if there is any kind of connectivity problem. So these are just, maybe I should pass it. Now it's an important, interesting part is now we want to generate our ticket using the LLM. So basically you see that we wrote an prompt here. We have instruction: analyze the following defect from the building facility, generate the Jira ticket. Yeah, that's the instruction we give, and then MCP using that to we then can create a ticket on the Jira based on that connection is already built up based on that client build up, already have a connection, and using that summary, all this instruction build up the summary of the ticket description, issues type, what is the problem that we find, which type of ticket, to whom it should return, and all this detail will be defined in that instruction. And then the Jira ticket is created. As you see here, that now we're creating the ticket. The MCP client tools it's already activating. It's via the JSON is load, and next step is that, okay, we do that MongoDB and we do cleanup, but okay, that part is not important. That it's already saying is the Jira ticket created, or is or there is any issues, there is this kind of things, we are doing that part. But basically this is the last part. So very simple. You set up your client, your server is not like the classical API connection that we should long understanding all the documentation. Here is very easy, very smooth. You can connect to the, if there is MCP provided by the platform, so you can easily connect and build up your application. Yeah, that was my second notebook I wanted to show you. And basically from my side, I show you these these three basically application, which here I show you about this ESG ESG factors, ESG application, which during the we use the LLM to extract the knowledge and build up our knowledge graph, and then we use that knowledge graph as a graph rack base for the LLM to answer the question and to build up the response, to generate the response. And that was very explainable inside. Second, I show you building maintenance management. I know it was very fast, but it's an assistant for the facility management task. And a main core of the system, as I show you, it is the knowledge graph, which understanding all the facility, all the tasks to be done for the facility is connecting to the legal norm standard platforms to get updated for the different regions. Of course, it's taking time to build up all this connection, and still we are develop for the German-speaking countries. And then I show you as a part of this application also how you can connect to the let's say target system, or the to target system like a Jira ticketing planner system, to do some action based on your application, to further to do something. And as you saw here, we use the LLM again to instruct how to which kind of action should be done, and MCP enable us to connect, to do connectivity with that platform's external platform. Yes, that's basically our the showcases I wanted to show you. Any question, discussion, any idea about that platforms, or in this? Could you please repeat the way to link up the rank and knowledge graph before invoking the you mean the rack and knowledge graph? I see. Basically, the knowledge graph that we use, it is we didn't link. It is actually we build up this knowledge graph when you're using it in Neo4j, and then you are just using this knowledge graph as a it's using it as a, it's embedding a whole the knowledge graph as an input for the LLM. So we are not connecting some kind of, it's a based on that when you have connection to that, you have your RAG system. So you can say the knowledge graph itself is a basis or the content of your RAG system. I hope that is clear. That was then this connection, then you give that context to your LLM. Okay, thanks that you understand. Okay, thank you for your great feedback. Makes me happy. So yeah, that's basically from these two application. So let's wrap up. That summarize what we're talking about. I did wrote a short summary. Of course, it's not a big one. Yeah, I just tried in the very short format showing you how the graph, and especially when we use in the knowledge graph, enable us deep understanding, complex reasoning, and clear explainability for the AI and agent system. So it's give us the more power and enable us to build up the system which are more explainable, trustworthy, and also we can interpret everything that is happening in our system. It's basically the graph rack is really game changing because it's not anymore, as already I said, it's not anymore just the vectorized base. It's really now we have idea anytime you can go to your Neo4j. Of course, when it's bigger, it's not so easy that I was now explore it, but it's possible. You can explore part of the graph. You can just load the part of the graph. You can write by the cipher query, just only get part of the graph and explore what's happening there, what is wrong in your data, which kind of inference based on what its inference happen and why this happened. And yeah, that we discuss about after that. Okay, we have all these bases which is give us a good context, but still we need the connectivity communication to bring the data from the different sources or do the action in other platform, like as I show you in the Jira. This kind of autonomous we need the autonomous agent, and this MCP enable us to do this. MCP basically we said is a model context protocol which is securely and very standard. We don't need to every time repeat that kind of to write a new documentation, new authentication is very standard. Everything is under defined, and it enables us to do this communication seamlessly with any platform. And yeah, that it's based on, if you connect all these things together, you build up the agentic system, which is you can trace the decisions, you can explain the reason, verify sources, and very trustable basically. So I think I many times they repeat the word trustable, but I think it's very important because most of the time our problem at the moment, we don't know what this AI system doing, and with that we are able to get to that level of trustworthiness. Then yeah, that what is the next, or what of course I believe these are really not real next future, but let's say short future, short-term future, not really long-term, that automated knowledge graph construction, that AI agent building and continuously updating knowledge graph, which is basically, I show you already, we do this in our platform. Is not, as I'm saying, is the short term. Still we are experimenting how to do this to have a good performance, because knowledge graph sometimes has also limitation to build up, and also need some resources. This we cannot avoid it. But if we have this kind of agent themselves continuously do the extraction and do the, I show you, we do the automatically autonomous updating of our knowledge graph based on the new norm, standard and legal stuff. And proactive agent that anticipate needs, monitor system initial action autonomously. So they say, for example, in our system also, what one example could be that it's self-deciding to what level escalating the problem. If, for example, if the issue is not so big, if it's just, I don't know, the bottom of the elevator is just the color is not here, it's gone, so it's not a big issue, it's not so much necessary to do the escalation. But if it's really there is a security problem, and then it's definitely necessary to escalate the problem to the higher persons with the higher responsibility. So that's here coming to that is agent themselves deciding to what is the necessary, to what when is necessary to do something. Advanced reasoning, of course, by integrating the graph rack, you have also possibility to go to the neuro-symbolic AI as one of the state of art, one of my favorite area at the moment in the area of the AI, which is enable you to do neuro-symbolic using the logic base with the neural network combination. It's a powerful method to do inferencing for sophisticated query and complex information need. And also a broader MCP adaptation, enabling integration to any virtual enterprise tool, because at the moment, let's say many places we have still API, but integrating more and more broad MCP into all platforms. And yeah, implementing like sampling and initiation to enhance agent decision. AI asks for more analysis, AI asks user for clarification. This is stuff that we're giving that more security and authentication. Good. Basically, we have 5 minutes. I would be happy to get more question. Otherwise, I would love to get in connection and also know about what you're doing. If you have any idea to build up this kind of platforms, please contact us. We can, in any case, can help. We would be happy to have more discussion and communication with you. So I will check if there is any question. Okay, no question. Yes, basically, yeah, I would happy to have question. Otherwise, you have I will share again. You have my contact. Please write to me, and yeah, I will be happy to discuss further any other potential discussion questions. Yeah, from my side, I would say thank you, and yeah, happy to keep in touch with you.